This section will be about solving problems using the divide and conquer techniques. In this video, we will learn how divide and conquer algorithms work by going through an example problem. Firstly, we will introduce the subject and describe how the divide and conquer technique works. Next, we will present an example problem where this technique is useful. We will then define the problem more precisely so we can later solve it more easily. Divide and conquer solutions rely on three main steps. Divide the problem into smaller subproblems, conquer the problem once it's small enough to be solvable, merge the solutions of the subproblems into a global one for the entire problem. Divide and conquer algorithms are usually useful to solve difficult problems, but for which the solution becomes trivial if broken down into small enough parts. We shall now present an example problem that demonstrates this. Bob the farmer is back. He wants to diversify and has decided to start growing some crops in his fields. However, he has a problem. This particular crop is quite temperature sensitive. He's not sure if the climate around his farm is adequate enough for the yield to be cost effective. The type of crop he wants to plant is not bothered by cold snaps, that is when the temperature drops. However, the harvest would be badly affected if the temperature rises too far from the minimum. So Bob went to the Met Office and obtained average daily temperatures for the previous years. Using these records, Bob wants to find out the rise in temperature from the minimums during the growing season. He can then use this data to determine if he's likely to make a profit or not. Here is an example of a historical temperature lasting the entire growing season. Let's plot it on a chart so we can view it better. As we explained before, we don't need to worry if the temperature goes down, as in this instance. What we are concerned with are increases in temperatures. Increases such as this one. The crops are badly affected when there is a rise in temperature from a minimum. For every temperature sample lasting a season, we want to find out the maximum temperature rise from a minimum. To put it more precisely, we want to find x, a temperature rise such that x is maximum for our sample data. You might think that we could first locate the minimum temperature, then look for the maximum after that date and find the difference. However, this is not a good solution. Let's look at a different example. The minimum temperature for the sample data is here, and the maximum after that is here. If we had to use this technique, we would be incorrectly calculating the temperature difference during this increase. The increase here would be just 10. The correct place where the temperature increase is at a maximum is of course here. In this case, the temperature increase is 18 degrees. So what's a better solution? The problem becomes a bit simpler if we re-encode our sample data from temperature to differences. Say we have the following sample data. We can compute the difference in temperature for every day. Rises in temperature result in a positive difference, while falls in temperature give negative ones. If we then put this in an array and discard the rest, the problem becomes that of finding a subarray where the sum of elements in that array is the highest. A subarray is a continuous part of an array. It can be one element, or an entire array, or just a smaller part. The important thing is that it is continuous. In this problem, we want to find the subarray, where if we sum up the contents, the result is the highest of any other possible subarray. This particular problem is called the maximum subarray problem. For example, this subarray has a sum of 13. However, it's not the largest, as this subarray has a sum of 17, which is larger. This particular one is the maximum subarray, as you cannot find any other that has a larger sum. It is equivalent to the maximum increase in temperature shown in the chart. Solving this problem will help Bob decide if he should bother with crop farming or not. Basically, a maximum subarray always has the largest sum. In this video, we introduced the divide and conquer technique, and we presented a problem that can be solved using this type of algorithm. We have finally better defined the problem.